So today we're going to talk about rational expressions, and a rational expression is basically just a fraction. Okay, so it's an algebraic fraction whose numerator and denominator, top and bottom, and denominator are just going to be polynomials. Remember, we talked about how from this point forward, factoring is going to be huge, okay? So think about what you can never divide by, and that number happens to be a 0, so you can never have a 0 in the denominator. That would make the fraction undefined. And we've talked about this before. We've said that if you have a number n over 0, what does that spell? And it spells no, so it's like no way, it doesn't work. If you had 0 over a number, and if we call the number the letter k, then that's okay. And that just becomes an answer that is just 0. So 0 on the bottom, no way. 0 on top is okay. Values that make the denominator equal to 0, which causes a rational expression to be undefined, and that's what we're trying to find. So what things make them undefined, and we happen to call those values either excluded values, or sometimes you might hear them referred to as restrictions. So numbers that make the denominator a 0, make the denominator and the whole problem undefined, are considered to be excluded values or restrictions. So the way that we find excluded values is we're only worrying about the denominator. So you're going to set the denominator equal to 0. You're going to factor that denominator if necessary, and then you're going to solve. And whatever you get as your answer, that's the excluded value. That's going to make the fraction undefined. So we're only worried about denominators. Numerators are irrelevant. If we set the denominator equal to 0 and we solve, then r being 8 is the excluded value. That would make this whole problem be a 0. On the second one, if we only worry about the denominator, numerator is irrelevant. If we set this denominator equal to 0, we have to factor. There's a GCF. We've got to solve it. This one is going to be x equals 0. This side is x equals 2. In this case, there are 2 excluded values. There's 2, I think I spelled this wrong too, EXCLUDED. There are 2 excluded values, and those are going to be 0 and 2 because that's going to make this whole fraction undefined. As we keep going, what's going to make the denominator a 0? Well, numerator is irrelevant. Denominator gets set equal to 0. It gets factored, x plus 3, x plus 2. It gets solved, negative 3, x equals negative 2. These values are the excluded values. These are the 2 numbers in which this fraction will become a 0. Last one here, again, denominator is all we're worried about. Numerator is irrelevant. The excluded values here, factor by dots. Again, the factoring should be quick these days. So these happen to be your excluded values. Okay, so that's all the excluded value stuff. So a rational expression, and we're going to start simplifying stuff. A rational expression is in simplest form when the numerator and the denominator have no common factors other than a 1. So what we're going to start doing now is simplifying these rational expressions. And in order to do that, you're going to have to factor, if need be, so factor both top and bottom. Once you're factored completely, not until then can you start dividing or canceling out common factors. We're going to tell you that we're going to assume that no denominator is equal to 0, which means we're not going to have any restrictions here. All the answers are going to work, okay? So we're not doing the excluded values at this point. We're just telling you that no denominator is going to be equal to 0. So you need to look at the problem. Number 1, can you factor the numerator? and you can. It's factorable by GCF. So 2 comes out, x plus 5 is left over. Can you factor the denominator? And no, you can't. So this then comes over as x plus 5, but understand it needs to be in a parenthesis because it's actually a binomial. Now, do we have anything that's common to this problem? And we do. These two parentheses, these two binomials are common, and your answer comes out in simplified form of just a 2. You should always be putting parentheses around binomials that are not factorable or anything that's not factorable so you can cross stuff out. Let's take a look at the next one. All right, can you factor the numerator? Absolutely, it's dots. X minus 5, x plus 5. Can you factor the denominator? You sure can. It's by a GCF. 3, x minus 5. Are there any common factors? And there are. This whole parenthesis, this binomial, cancels this binomial. And your final answer then becomes x plus 5 over 3. Let's keep going. Can you factor the top? Absolutely. GCF. 4, x plus 7. Can you cancel the bottom? Can you factor the bottom? Sorry. And you can by I am. X plus 7, x minus 1. Do we have any common factors? And we do. This binomial and this binomial cancel, which means your final answer in simplified form is 4 over x minus 1. The next part is pretty much the same, except what you have to be careful about is if you're trying to have common factors or factors that are opposites, okay? If that's the case, you have to cancel out, or sorry, you have to factor out a -1 before you cancel common factors. What I mean is this. Take this simple expression. If we asked you for 4 divided by -4, the answer is not 1, it's -1. Okay, if we asked you for something like negative x divided by positive x, the answer is not 1, it's -1. So if your factors are opposites of one another, then they cancel to a -1. So let's see what happens. This top cannot be factored. It should go in parentheses. This bottom can be factored. It's dots. But now 9 comes first. So 9 square root is 3. So it's 3 minus x and 3 plus x. So we have to determine whether we have opposites. And the things that look pretty much the same are this and this. And the question is, are they opposites or is it the commutative property that's working here? And in this case, they're not opposites because whatever x is, if let's say x is 2, 2 plus 3 is 5, 3 plus 2 is 5, right? So they would just not be opposites, they would be the same. And what I would be able to do is cross out them completely. This answer says I've got 3 minus x on the bottom with a 1 on the top. Okay, so in this case, these were not opposites. They were the same. I was able to cross them out and not worry about a -1. Let's take a look at this guy. This top can be factored by GCF, 5x minus 4. This bottom can't be factored, but it's 4 minus x. Take a look at these guys now. X minus 4, 4 minus x. These are opposites. So if we were to plug in a value for x again, just to kind of test it, if I put in a 2 here and a 2 here, and I did the math, I'd get a -2 on the top and a +2 on the bottom. Those are opposites. So when these guys cancel out, you're left with a -1 somewhere. Doesn't matter where you put it. So if I leave that -1 on the bottom, I get 5 over -1, but bottom line, the answer is -5. So when there's subtraction, you can have opposites. So you're looking for opposites can occur with subtraction. Okay, let's try this last one. On the top, I've got an I am, x minus 3, x, let me fix that, x plus 3, x minus 5. On the bottom, I've got a GCF of a 2 and a 5 minus x. These guys, x minus 5, 5 minus x, they're opposites. So when I cancel them out, I'm going to be left with a negative 1 somewhere. I'm going to put that negative 1 on the bottom, which means I've got x plus 3 on the top, and it's really 2 times negative 1, which becomes negative 2. That's one way to write the answer. Some people might want to put the negative on the top, negative outside the parentheses, x plus 3 over 2. Doesn't matter. Okay, so there you go.